Hi, we're inteGREATEST, and this is our AP Calculus AP 2013 FRQ number 1 group video. So for our problem, it states, on a certain workday, the rate in tons per hour at which unprocessed gravel arrives at a gravel processing plant is modeled by G of t equals 90 plus 45 cosine t squared over 18, where t is measured in hours and 0 is less than or equal to t, which is less than or equal to 8. At the beginning of the workday, when t equals 0, the plant has 500 tons of unprocessed gravel. During the hours of operation, when 0 is less than or equal to t, which is less than or equal to 8, the plant processes gravel at a constant rate of 100 tons per hour. In this video, we'll show you how to solve this problem. Alright, so part A asks us, find g prime of 5. Using correct units, interpret your answer in the context of the problem. So the first step to finding the solution to this problem is finding g prime of t, or the derivative of our original g of t function. So to take the derivative of 90, which is a constant, it's just 0. And to take the derivative of this portion, it's negative 45 sine t squared over 18. And then we have to chain the part of this problem which is in the parentheses. And that is 2t over 18, giving us a derivative of negative 5t sine t squared over 18. So next we have to actually find g prime of 5. So we are going to plug in 5 in the place of t in our derivative function. And that gives us negative 24.588 tons per hour squared. So next we have to figure out how to interpret this answer in the context of the problem. So essentially what this is saying is the rate at which unprocessed gravel is arriving at the plant, that is changing by negative 24.588 tons per hour. Or in absolute value terms, we would say that it is decreasing by 24.588 tons per hour per hour. Alright, so in terms of points for this problem, there are 2 possible points you can get. The first is for finding g prime of 5 and showing the work for all of that. And the next part is for interpreting in terms of the units, which we have over here, and interpreting the problem in the context of the problem, which we have here. So there are a couple of concepts that you need to know to successfully solve this problem. First, you need to be able to solve for the first derivative of the function. And second, you need to be able to understand how that first derivative is implemented in the context of the problem, and how it fits in and what that answer would mean. Alright, this first person was able to receive full credit, the full 2 points, because they were able to find g prime of 5, which is negative 24.588 tons per hour squared. And they were able to justify their answer in the context of the problem with correct units. The second person only received 1 point because they were only able to find g prime of 5, but they were not able to sufficiently explain their problem and justify it like the first person did. The last person had a similar problem and was able to find g prime of 5, but have no justification for their answer. Alright, some common errors that students made on this problem was putting incorrect units, which is part of receiving full credit. Some people were unable to correctly interpret g prime of 5. Some people forgot to indicate that g prime of 5 represents change at when time is 5 hours. And some students said that g prime of 5 related to an interval of time.
Okay, so for part B, it says find the total amount of unprocessed gravel that arrives at the plant during the hours of operation on this workday. So the problem already gives you the amount of gravel unprocessed gravel that arrives at the plant. So all you have to do is find the integral from 0 to 8, which is the workday hours it gives you in the problem of g of t dt. So the function is 90 plus 45 cosine t squared over 18, and then dt, and then that'll give you 825.551 tons in that interval. And so the way you go about doing this is that in your calculator, you put in NY1, 90 plus 45 cosine x squared over 18, and then you go to the regular menu page, and then you go math, and you go all the way down to 9, and then you go to the integral, and then plug everything in, and then in here, you put y1 in vars, so you go y vars function y1 in here, and then dx, and then I'll give you your answer. Okay, so for the rubric, for the 2 points you get for this problem, you get 1 for showing the integral, which is right here, and then 1 for the answer, right here. Alright, so for part B, some concepts you really need to know is just integration, how to take an integral of a function, and when you're asked to find the total amount of something in a problem, you use integration. And so you can see here, everyone got full credit that did it in the student samples because they took the integral and they got the correct answer.
Part C is asking, is the amount of unprocessed gravel at the plant increasing or decreasing at the time t equals 5 hours? So to find the rate at which the gravel is arriving, you would have to plug in 5 into the original equation, which would be 5 equals 90 plus 45 cosine 5 squared over 18, and that'll come out to be 98.141. Then you look back at the original problem and see that the gravel is being processed at a rate of 100 tons per hour. And if you compare 98.141 to 100, you would see that the rate at which the gravel is being processed is greater than the rate at which it's arriving, which would show a decreasing amounts in gravel in the plant. You get 1 point in this question for showing that 98.141 is less than 100 tons per hour. And in saying that, you get another point for the conclusion, being that at 5 hours, the rate at which the gravel is arriving will be 98.141, which is less than 100, showing that more gravel would be processed than would be arriving, which would be a decrease in the amount of gravel being processed in the plant. The key concept for part C would be comparing rates. It's necessary to know that the rate that gravel is being processed is greater than the rate that gravel is arriving. The first student created an equation, Vt equals Gt minus 100, 100 being the rate at which the gravel is being processed, and Gt being the rate at which the gravel is arriving. And they plugged in the 5 to represent the rate at 5 hours. So they ended up getting negative 1.859, which shows that the amount of unprocessed gravel would be decreasing at 5 hours. Student number 2 calculated first the rate at which gravel is arriving at 5 hours, which would be 98.141, and compared it to 100 tons per hour, the rate at which the gravel is being processed. And from that, they determined that the amount of gravel is decreasing at 5 hours. The third student received 0 points because they only calculated the amounts arriving at the plant during 5 hours, which from that they got a positive amount since they didn't calculate the amount being processed per hour. Some common errors in part C would be finding an expression for the rate of change in the amount of unprocessed gravel. Some examples would be the students finding G5, G prime 5, G prime 5 minus 100, and G of 5 minus 500.
So for part D, the problem states, what is the maximum amount of unprocessed gravel at the plant during the hours of operation on this workday, and justify your answer. So we start off by creating a function that shows the amount of unprocessed and processed gravel in the plant. So since the problem tells us that there are 500 tons at time equals 0, we write 500 here. And G of T is the amount of unprocessed gravel that is arriving, and 100 is the amount of gravel the plant is processing. And since we want to find the maximum amount of unprocessed gravel at the plant, we take the derivative of the whole equation. Since 500 is a constant, it goes to 0. And according to the fundamental theorem of calculus, by taking the derivative of an integral, you just get G of T minus 100. And then if you plug in the function for G of T, which is given in the problem, you get 90 plus 45 cosine T squared over 18 subtracted by 100. And if you take this equation and plug this into your calculator, you want to find where the function intercepts x between the integral 0 to 8, because that is the workday hours, and you'll find that the function intersects the x-intercept at x equals 4.9235. So the critical point for this function is at 4.9235. So for the second part of the problem, since you need to find the maximum amount of unprocessed gravel, you already have the critical value at T, which is equal to 4.9235. The other potential maximum amounts could be at time equals 0 and time equals 8, which are the two endpoints of our function. So you plug in 0, 4.9235, and 8 into the original equation. And then you get that 0 equals 500, 4.9235 equals 635, and 8 equals 525. And since at T equals 4.9235, there's the greatest amount of unprocessed gravel, your answer is at time 4.9235. The plant has the most unprocessed gravel, which is 635.376 tons. The first point for this problem is comparing a prime of t to 0, so finding the critical number for a prime of t. And then the second point is for getting the correct answer. And then the third point is for justification, showing how you got the critical value and plugging in the possible maximum x values into the A of t equation. So some key concepts you need to know to solve problem D is to know how to write the function using an integral. The second concept would be to be able to find the first derivative and know that taking the first derivative of an integral includes the fundamental theorem of calculus, and understand what the first derivative means in the context of the problem. The third concept is finding the x-intercept using the graphing calculator, and then understanding that the x-intercept in the context of this problem means that the x is the critical value. So student A got 3 points, which is full credit, because they were able to compare a prime of t with 0 and find the critical number. This student, instead of using a prime of t, they just changed the variable and used v prime of t instead. They were able to find the correct answer of t equals 4.923, which gave them the second point, and they provided justification, which gave them the third point. Student B got 1 point because they were able to compare a prime of t to 0 and they got the correct critical number. However, they did not provide the correct answer, and thus their justification was incorrect as well. The last student, student C, got 0 points because they were unable to find the critical value and find a prime of t at equal to 0, and they found the incorrect amount of tons, and so their justification was also incorrect.